Hi everyone, in this video we shall go to understand the reset set flip-flop. So as I already told you, we are going to discuss about flip-flops first. Once we finish the flip-flops, then we are going to go towards the shift registers, then we are going to go towards the counters, and then where we are going to finish them off, right? So this is your fifth unit, first main concept, that is RS flip-flop. What do you mean by R? Reset. What do you mean by S? Set. Reset, set, flip-flop. So without wasting much time, let me take you people to the block diagram of the SR flip-flop or RS flip-flop. S is the set input. Okay, let me just grab a highlighter. Okay, so S is the set input, R is the reset input. When you give the set input and reset input to the SR flip-flop, you will get two outputs, Q and Q bar. Q is one output, Q bar is the one more output. So SR flip-flop has two inputs and two outputs. Okay, so this is what we understand by seeing the block diagram. So now let us go to understand the logic diagram. So the logic diagram of the SR flip-flop or SR latch is having four NAND gates. NAND gate 1, NAND gate 2, NAND gate 4, NAND gate 3 and NAND gate 4. Okay. So this four NAND gates are there. So first S input, set input is connected to the NAND gate 3. I mean both the inputs of the NAND gate are connected to the same input. What is that input? That is set input. Similarly, R is the input that is given to the NAND gate 4. Both inputs of NAND gate 4 are connected to R. What do you mean by R? Reset input. Okay, so the output of the N3 gate is given to the N1, N4 gate output is given to the N2, and the output of N1 is called as Q. This Q is given as one more input to the N2. Similarly, at the same time, Q bar is taken and it is given as one more input to the N1. This is what your logic diagram. Okay, this is what your logic diagram of your SR flip-flop. Okay, so now, okay, very simple logic diagram, right? There is no difficulty in this. Okay, just you have to remember that S is given to N3, R is given to N4, output of N3 is given to N1, N4 output is given to N2. So Q is taken as the second input to N2 and Q bar is taken as the second input to the N1. Okay, this is how the logic diagram connection goes on. So let us go to the truth table. What happens in the truth table? So we have inputs, we have outputs, and we have comments. Okay, so in the inputs we have S and R, these two are the inputs. Q and Q bar are the outputs. Okay, so without wasting much time, let us try to understand the truth table of the given SR flip-flop. What happens here? When S input, set input and reset input both are 0, S is equal to 0 and R is equal to 0, what happens here? Q is equal to Q bar and Q is equal to Q and Q bar is equal to Q bar. I mean the flip-flop is not at all going to change its state, because both the set and reset input both are 0, both are null. That is why the Q remains Q and Q bar remains Q bar. What do you mean by Q and Q bar? Q and Q bar are the outputs, right? So the outputs are going to remain same. There is no change. Okay, there is no change in the output. That is why the flip-flop, what flip-flop it is, RS flip-flop is said to be in the no change state when you give 0 and 0 as the input. Okay, let us understand the next state. Okay, what happens here? Set input is 0, reset input is 1. Okay, as set input is 0 and reset input is 1. Okay, so the reset output Q bar is going to be 1 and the set output or Q is going to be equal to 0. Q is equal to 0 and Q bar is equal to 1, as we have given the reset input high. Okay, so what happens here? Here the flip-flop moves into the reset state. Okay, and in the next state, or in the next illustration, or in the next iteration, okay, so of the truth table, here we have set input is equal to 1 and reset input is equal to 0. Set is equal to 1 and reset is equal to 0. Then output q is equal to 1 and q bar is equal to 0. This state of the flip-flop is what we are going to call it as set state of the flip-flop. The flip-flop is going to go into the is going to get into the set state. Okay, so again we have one more input, that is s is equal to 1 and r is equal to 1. When both inputs are 1, q is also equal to 1, q bar is also equal to 1, wherein when q is equal to 1, q bar cannot be equal to 1, because q bar is the complement of q. If q is equal to 1, q bar must be 0. If q is equal to 0, q bar must be 1. Understood? So as both cannot become 1, what happens? This state of the flip-flop is what we are going to call it as invalid state. This is called as invalid state. Okay, this is not a valid state of your flip-flop, and that is your truth table of SR flip-flop. I repeat, when you have 0 0 as the input, output will be q bar, and that state of flip-flop is called as no change. When you have 0 1 as the input, the flip-flop q is equal to output of the flip-flop q is equal to 0, q bar is equal to 1, and this state of the flip-flop is called as reset state. When you have 1 s is equal to 1 and r is equal to 0, when you have 1 0, the output q is equal to 1 and q bar is equal to 0, and this state of the flip-flop is called as set state. And then we have one more input type, that is 1 and 1. When you have s is equal to 1 and r is equal to 1, q is equal to 1 and q bar is equal to 1, and this state of flip-flop is what we are going to call it as invalid state of the flip-flop, because it is not going to be valid. If q is equal to 1, q bar should be 0. Okay, so this is what the truth table. Once you understand the truth table, let us try to answer the working of the flip-flop. Okay, so the first 3 basic points I would like to tell you people first, and then let us go to the truth table answer or working of the RS flip-flop. The RS flip-flop is a reset set flip-flop. What is RS flip-flop? RS flip-flop is a reset set flip-flop. This point is what we already know, right? Yeah. Then it has 2 inputs. What are the inputs? S and R. What do you mean by S? Set. What do you mean by R? Reset. Let it be. It is having 2 inputs, S and R, and it is having 2 outputs, that is Q and Q bar. Okay, so it is having 2 inputs, S, R, it is having 2 outputs, Q, Q bar. This is the second point. Then we have the input S is called as set input, and the input R is called as a reset input. S is called as set input, R is called as reset input. These 3 are the points that you can easily write by using the diagram. By just looking at the diagram, logic diagram, you people can write these 3 points easily. Then let us try to understand the working. So how shall we write the working using the truth table? If S is equal to 0 and R is equal to 0, the flip-flop remains in its previous state. The flip-flop remains in its previous state, giving you the output Q is equal to Q and Q bar is equal to Q bar. This is the first point. Okay, so next point what we are going to discuss here, if S is equal to 0, if set is equal to 0 and a reset is equal to 1, the output Q is equal to going to be 0, but Q bar is going to be equal to 1, and this is called as the reset state of your flip-flop. The flip-flop is going to get into the reset state when you have S is equal to 0 and R is equal to 1. So then what happens, if S is equal to 1 and R is equal to 0, the output Q is equal to 1 and Q bar is equal to 0, and this state is called as the set state of the flip-flop. Okay, so in the next point, let us put S is also equal to 1, R is also equal to 1, the output Q is equal to 1, and even the Q bar is equal to 1, and this state of the flip-flop, S is equal to 1, R is equal to 1, output Q is equal to 1, and Q bar is equal to 1, and this state of the flip-flop is what I'm going to call it as invalid state, because when q is equal to 1, q bar must have been equal to 0, as this is not possible, as this is not existing. So that is why we are going to call this as invalid state. So this is what the clear explanation regarding the reset set flip-flop, block diagram, logic diagram, truth table, and the answer. Okay, so next let us go about discussing one more important flip-flop, that is your clocked RS flip-flop. Before going to clocked RS flip-flop, I just want to grab a eraser. Let me take a eraser. Oh god, okay. So I just erase all these markings what I have done using the highlighter. Okay, done. Let me go to the clocked RS flip-flop. So in the clocked RS flip-flop, what happens here? So let us go to the block diagram first. Block diagram of the clocked RS flip-flop. So RS flip-flop is very similar to that of your clocked RS flip-flop. The only change that we are going to do to the RS flip-flop to make it clocked RS flip-flop is we are going to add a clock input along with the yes and R. Along with yes and R, we are going to add the clock. So that is why it is called as clocked RS flip-flop or clocked SR flip-flop. Okay. The outputs are going to remain same, Q and Q bar, and this is the block diagram of the given clocked RS flip-flop. Then let us try to understand the logic diagram. Here the logic diagram is going to be very simple, very similar. What happens here? S is one of the input, R is one of the input, and clock is one of the input. The clock is given to both NAND gates N3 and N4. S is given as the input to N3, R is given as input to N4. The output of N3 is connected to N2, the output of N4 is connected to N1, and the Q is connected as second input to the N1, and Q bar is connected as second input to the N2, and N2 output is Q, N1 output is Q bar. This is how we draw the logic diagram of the clocked RS flip-flop. Okay, so once you understand the logic diagram of the clocked RS flip-flop, let us go to understand the truth table of it. So just observe the truth table of the clocked RS flip-flop. It is very similar to that of your RS flip-flop or SR flip-flop, but here the only change that we have is we have clock pulse added along with the input output comments section. Okay, along with input output and comments, we have one more section that is called as clock pulse. So when S is equal to 0, R is equal to 0, after applying the clock pulse, Q will be equal to Q and Q bar will be equal to Q bar, and this state of the flip-flop is what we call it as no change state. Then in the next case, when S is equal to 0, R is equal to 1, after applying the clock pulse, Q will be equal to 0, Q bar will be equal to 1, and then we call the flip-flop is moved into reset state. The flip-flop has moved into reset state. And then in the next case, when S is equal to 1 and R is equal to 0, after applying the clock pulse, the Q will be equal to 1 and Q bar will be equal to 0. Okay, so this state of the flip-flop is what I'm going to call it as set state. Okay, then in the next instance, when S is equal to 1 and R is equal to 1, after applying the clock pulse, Q will be equal to 1 and Q bar will be equal to 1, and this cannot happen because Q bar is the complement of Q. If Q is equal to 1, Q bar must be 0. If Q is equal to 0, Q bar must be 1. That is why this state of the clocked RS flip-flop is also called as invalid state of RS flip-flop, clocked RS flip-flop. Invalid state of clocked RS flip-flop. This is the truth table of the clocked RS flip-flop. Let us go to understand the working. Before taking you people to make you understand the working, I'll just erase all the highlighted marks whichever that I've made on the screen, and then I'll take you people to the next slide. Let me just grab a highlighter, get back. Okay, the first point, what he says here, the clocked RS flip-flop has 3 inputs, R, S and clock, and you can extend the answer like the clocked RS flip-flop has 3 inputs and it is having 2 outputs. What are the outputs? Q, Q bar. Finish. Your point, first point is over. Okay, very easy, right? We know that clock direct flip-flop is having three inputs. What are the three inputs that we have? R, S, and clock. That is what I've written over there, right? So next we are going to extend the same answer like, okay, the clock direct flip-flop has three inputs, R, S, and clock, and is having two outputs, that is Q and Q bar. That is finished. Let us go to the first point again. Okay, in the next point again, here if S is equal to 0, R is equal to 0, after applying the clock pulse, or the clock pulse is applied, then the output of the flip-flop will be same as the output before. The output of the flip-flop will be same as the output before. That is why this state is called as no change state. The flip-flop is going to get into no change state when you apply S is equal to 0 and R is equal to 0. Okay, after applying the clock pulse, the flip-flop moves into no change state. Okay, then if my S is equal to 0 and R is equal to 1, after applying the clock pulse, Q is equal to 0, Q bar is equal to 1, and the flip-flop is into reset state. The flip-flop is into reset state. This is very, very important point. You have turned on the reset input and your flip-flop is into reset state. Understand this properly. Okay, so when my input S is equal to 0, R is equal to 1, the Q is equal to 0, Q bar is equal to 1, the flip-flop is going to get into reset state. Let us go to the next point. That is, if S is equal to 1 and R is equal to 0, the output after applying the clock pulse is Q is equal to 1 and Q bar is equal to 0. The flip-flop is now getting into the set state. The clock direct flip-flop is going to get into the set state. So here what happens? If my set input is equal to 1 and the reset input is equal to 0, the output after applying the clock pulse, here the clock pulse mentioning is very, very important. I have to say after applying the clock pulse. After applying the clock pulse, what happens? Q will be equal to 1 and Q bar will be equal to 0, and this state of flip-flop is what we are going to call it as set state of the clocked RS flip-flop. Then in the fourth case, we are going to consider S is also equal to 1, R is also equal to 1. The output after applying the clock pulse is Q is equal to 1 and Q bar is equal to 1. And as this cannot exist according to Boolean algebra, when Q is equal to 1 and Q bar must be equal to 0, the state of the flip-flop is what we are going to call it as invalid state. Understood? So I hope you people understood the working logic diagram and a truth table of RS flip-flop and clock RS flip-flop very well. If you do have any doubts, okay, if you people do have any doubts, you people can definitely ask me through any of the medium. And by this I'm going to end the video now. Okay, I am going to just end the video now. Okay, and by the next video we shall discuss the JK flip-flop, master slave JK flip-flop, and we have delay flip-flop. So though if we complete those three flip-flops, we'll be completing all the flip-flops. Fine. So in the further coming videos we shall discuss the shift registers and counters. Okay, have a very good day. Happy learning.